Hi folks, welcome again in Eng-Man YouTube channel. So we will continue our geoscience playlist and still about core analysis. Actually, we started this topic with Klinkenberg topic here, all right, where we did a correction for, for permeability due to Klinkenberg effect. Now we will continue the core analysis study with net overburden effect. All right, so it's very, interesting topic and quite simple actually. Hopefully we can cover this simply. All right. So often laboratory porosity measurements are done at ambient conditions without applying adequate overburden stress on the core samples, right? So this leads to erroneously high porosity and permeability values that should be corrected before using them in any reservoir engineering calculations and of course in reservoir simulation. All right. In most core analysis studies, however, some core samples are selected for porosity and permeability measurements under overburden stress or overburden effect. All right. And normally, these selected measurements are made at several values of net overburden stress or NOB and included in the report. All right. And so hopefully now we can learn something from that, where we already have the correction factor for net overburden stress, let's say from a core analysis report. And then we also have ambient porosity data. And what is the corrected porosity that we can use in our analysis and simulation? All right, so that's the idea here. And this is our case. I take this material from Dr. Ezat Goma. So he's an expert. He made a very interesting and important book for reservoir engineering. And I use the case and hopefully we can learn many things here. All right, so the case is like this. So we have a reservoir and the datum depth is at 3,550 feet. And we also know the overburden gradient, 1.03 psi per foot. And we know the reservoir pressure, all right, 1518 psig, and the fraction of reservoir pressure opposing overburden stress. All right, okay. And 0.85 is the fraction of the reservoir pressure that will oppose the overburden stress. Okay, and then we also have this very important table. And as I said before, in many core analysis report, we have this kind of information where we have some measurements that will get this correction factor for NOB for each net overburden stress. All right, stress, the unit for stress is PSI. Okay, and if we have these values, how can we use these values to predict or to correct or to get the corrected porosity here for any ambient porosity information that we have? All right, so that's the thing. And these are some formulas that must be used, can be used, very important. Porosity correction factor for net overburden is the porosity measured under overburden stress divided by porosity measured under ambient temperature. All right, so it must be below 1 because porosity in ambient condition will be greater than porosity measured under overburden. All right, because the rock will expand and the pores will expand under ambient temperature or ambient pressure. And then permeability correction factor for NOB. All right, the formula is the same with porosity. Permeability measured under overburden condition divided by permeability measured under ambient condition. And then what is the net overburden? Net overburden is this. So we have this sigma, which is overburden gradient, multiplied by the reservoir depth, subtracted by this. So alpha. Alpha is the fracture of reservoir pressure opposing overburden stress, and then alpha multiplied by the reservoir pressure itself. All right, so that's the formula that we will use. And so let's process this information first. I'm going to plot this. I'm going to use this information to make a plot of, the correction factor against the net overburden. So to make that, I will do something like this. All right. I will do, for example, like this. All right. 6 times. Okay. And then let's use, okay. Oh, by the way, we have 6 core samples, which are completed or which are used to get the correction factor for NOB. So we have 6 specialized measurements just to get the correction factor, right? The, the experiment or the trials to get correction factor will not be used for all core samples because that must be time consuming. So we just select maybe, like in this case, we only have 6 runs, 6 measurements, which are completed with correction factor for NOB measurement. All right, and then lastly, sample 38. All right, and so this is NOB, and we can say this as, correction factor. Okay, and then just color it. All right. And then we will use correction factor as the vertical axis. So I will click insert, this, scatter, and then right click, select data, add the X value will be the net overburden, and the Y axis will be this, the correction factor. All right, pretty easy. I'm going to add the access title like this. I will color them black instead of gray, and then just use this NOB, net overburden correction factor. Make them bold. Okay, and then this should be the NOB. All right, in PSI. And then this will be the correction factor. Okay. All right, and then just make a trend line, right? Like, right click, add trend line. And let's say we will use polynomial. So it's like this. It's quite good. Let's display the equation on chart and then R square. Okay, currently we are using powered by second order. Okay, let's try third order. Okay, I think it's quite good. And then for the number, maybe we can use number like this, and then for comma, maybe 6. Oh, too small, right? What should we use then? And then scientific. Okay. Let's try again. Let's say okay, third order, but just use 2 like this. Okay, and then just make it 1, something like this. So the correction factor will follow this correlation. Okay, and then sometimes we can also do like this. So I will switch it, move it to the right, and then NOB in 1000 psi. So I will divide them with 1000 and then double click here. And then we'll use the MPSI. It's like this. But it's, it's the same. All right. Okay, I will use this. And then I will make it clear. And then this bold, make it bigger. Okay, maybe 10. All right. And yeah, so we will use this and apply them in our table here. Okay, so we have now the correlation to get the correction factor with known net overburden. Okay, and then the table here, we know the ambient porosity. And we also know this, the overburden condition, 800, 1500, 2200, and 4100. Okay, but we need also to calculate the net overburden. And we will use this formula, the NOB. NOB is the, this one, the overburden gradient multiplied by the reservoir depth. So first, reservoir gradient, overburden gradient, sorry, multiplied by the reservoir depth. Okay, and then subtracted by, let's check it out, alpha multiplied by the reservoir pressure. So alpha is 0.85. Alpha again is the fraction of reservoir pressure opposing overburden and multiplied by the reservoir pressure. Okay, so now we get this. The net overburden stress is 2359 psi. Okay, so this is our NOB. Okay, very good. All right, and then, yeah. So now we will get correction factor with the known NOB. All right. And of course, with that, we will use to calculate the corrected pressure or corrected porosity. So I will use this, or maybe, yeah, maybe just use this correction, right? Correction factor. Let's say what's the symbol for that? Maybe, yeah, just use correction factor instead. Okay. Okay, here. And we will use this formula. Okay, so it should be minus 2.14 e to the power of minus 12 multiplied by NOB to the power of 3 and then plus 2.33 e to the power of minus 8 multiplied by NOB squared and then minus 8.59 e to the power of minus 5 multiplied by NOB. And lastly, plus 1 e to the power of, yeah, e to the power of just 1, right? Because there is nothing here, just 1. Okay, and then plus, and this is our correction factor. Okay, so it's 0.9, the correction factor. And we will use this correction factor to correct the ambient porosity and change it or translate it into the corrected porosity. So it should be, or it's very simple, the ambient porosity multiplied by the correction factor, this, and then block or lock the correction factor. Okay, I will use 3 significant figures and then just double click. All right, sorry, this is typo. And then we get that. All right, so rather than using this ambient porosity in your computation, analysis, simulation, you should use this corrected porosity. All right, why? Because this ambient porosity is measured under ambient condition, which, does not represent the reservoir condition. What represents reservoir condition should be this corrected porosity, because this is the porosity that exists under net overburden condition, right? Where your reservoir, where your rock experience overburden. Okay, so that's it. I think we can call it a day, right? So I hope you enjoy this video. I hope this video is useful. Thank you so much, and see you again in the next core analysis videos. Thank you.